From the very birth of the cosmos to the mysterious depths of supermassive black holes, the universe has unveiled its secrets through the lens of high-powered space telescopes. But have you ever wondered, beyond the breathtaking visuals, what the universe sounds like? Today, we're diving into the symphony of the stars. Welcome to Cosmic Discovery, where we explore not just the sights, but also the sounds of the universe. If you're as intrigued as I am, hit that subscribe button, because there's so much more cosmic harmony to come. Before we dive into these captivating cosmic audio clips, let me provide a brief explanation of how we managed to capture these intriguing sounds. You might be wondering how sound, which typically relies on a medium to propagate, could exist in the seemingly silent void of space as we perceive it here on Earth. It's true that traditional sound waves can't traverse the vacuum of space, but that doesn't mean space is devoid of all auditory experiences. In reality, space is teeming with a wide array of undetectable waves that elude our eyes and ears. Fortunately, our advanced telescopes and spacecraft can intercept these waves, such as radio waves, microwaves, X-rays, and more. Through a fascinating process known as sonification, we've transformed this data into audible sound, offering us a novel way to explore the cosmos. Now, let's embark on our cosmic auditory journey. The first of the 5 audio clips will transport us back to a time when the universe was in its infancy, before the birth of stars or galaxies. Picture a time when everything was a scalding, brilliant mix of dense plasma, and you'll soon hear the sound waves that grace this primordial era. In this extraordinary era, the early universe was filled with reverberating sound waves. These waves were set in motion by fluctuations that occurred just moments after the momentous Big Bang. As these sound waves traversed through the fledgling cosmos, they left their mark on both matter and light, akin to the ripples created on the surface of a pond when a stone is cast into it. These imprints manifested as faintly brighter and darker patches in the cosmic illumination. By deciphering these ancient light patterns, the Easter's Planck Space Telescope can essentially eavesdrop on the echoes of the primordial universe, producing a rather unusual 13-billion-year-old rhythmic hum. Our next audio clip transports us to one of the most enigmatic entities in the universe, a supermassive black hole, a colossal gravitational behemoth of such immense power that not even light can escape its grasp once it ventures beyond the event horizon, the point of no return. Remarkably, we can now tune in to the surroundings of this cosmic titan. This particular form of sonification is rather distinct from the others, as it delves into the actual sound waves derived from the data. Astronomers made a fascinating discovery. Sound waves emitted by a supermassive black hole situated 250 million light-years away caused ripples in the hot gas at the core of the Perseus galaxy cluster. These sound waves were extracted from the information gathered by NASA's Chandra X-ray Observatory and transformed into audible form, allowing us to listen to the eerie, intergalactic howl of a distant supermassive black hole resonating throughout the universe. When we consider the observable universe, it's estimated that approximately 2 trillion galaxies exist, each comprised of billions upon billions of stars. Our very own star, the Sun, is the closest to us and serves as a prime example of what these colossal incandescent orbs of hot gas sound like. Over the years, numerous spacecraft have studied the Sun, but the one that has ventured closest, yielding the most exciting data, is NASA's Parker Solar Probe. This spacecraft made direct contact with the Sun. swishing and whistling sounds you've just experienced are a result of pressure waves emanating from the hot, electrically charged particles in the solar wind that radiates from the sun's delicate outer layers. Known as Whistler mode waves, they are generated by energetic electrons bursting forth from the sun's corona, the outermost layer of its atmosphere. When these waves are converted into audible sound, they bear a resemblance to a tumultuous roar or a hurricane's fierce howl. It's believed that, on average, every star in the Milky Way galaxy hosts at least one exoplanet in orbit around it. With an estimated 100 billion stars in our galaxy alone, and countless other galaxies with billions of stars, the universe likely teems with various types of planets encircling these stars. According to NASA's Exoplanet Archive, the most common type of exoplanet discovered thus far is Neptune-like. To gain an auditory glimpse of what these exoplanets might sound like, we can listen to the plasma wave data recorded by the only spacecraft to have ever visited Neptune, Voyager 2. Consider exoplanets as celestial bodies with atmospheres primarily composed of hydrogen and helium, resembling the size of Neptune or Uranus, both of which we refer to as ice giants within our own solar system. The intriguing audio clip you just experienced captures the intricate interplay between the charged particles in the sun's solar wind, which we explored earlier, and Neptune's ever-evolving magnetosphere. This magnetosphere encompasses the region around the planet and is dominated by its magnetic field. The outcome is a peculiar, almost solitary hum. You might assume that the vast expanse between stars, known as interstellar space, is a desolate void, utterly devoid of substance. However, it harbors extensive quantities of dispersed dust, gas, and cosmic rays. Thanks to NASA's Voyager 1, we can now listen to the haunting resonance of this peculiar and desolate realm. Voyager 1 achieved a remarkable milestone as it became the first spacecraft to venture into interstellar space, surpassing the sun's heliosphere, which forms a protective bubble of solar wind encircling our solar system. The recorded audio unveils the mesmerizing symphony of electromagnetic waves resonating within the plasma that permeates the space between the stars. It also captures the sounds of charged particles colliding with Voyager's instruments. Similar to the ocean, the interstellar medium is replete with turbulent waves, originating from phenomena like the galaxy's rotation, supernova explosions, and the influence of other stars. These waves offer valuable insights into the interstellar medium's density and our position within the galaxy. Listening to these almost eerie audio recordings allows us to peek into the auditory dimension of the universe, which eludes our visual and auditory senses. This underscores that space is far from the silent void it might seem. With the aid of cutting-edge telescopes, spacecraft, and other advanced technologies, scientists continually gather fresh data on these cosmic sounds. Who knows what other celestial marvels we will uncover through the language of sound in the future? I sincerely hope you found this video enjoyable. If you did, please consider giving it a thumbs up. And if you haven't already, why not subscribe? There's plenty more fascinating content to come. Thank you for tuning in, and I look forward to seeing you next time.